When we multiply and simplify roots that are not the same type of root, or in other words, they don't have the same index number, we need to first change them to exponential form. So this first one is going to be b to the 6/9, and then we're going to times that by b to the 3/2. Once we've changed them to exponential form, we check to make sure the bases are the same, and think back to our exponent rules. If the bases are the same and the bases are being multiplied, we're going to add the exponents, and that requires, in our case, finding a common denominator. So I'm going to leave the base the same and find the common denominator, which is 18. To change this 9 into an 18, we had to times by 2, so 6 times 2 would be 12. And then we're going to add this 2 to change it to an 18. We had to times it by 9, so we got to change the 3 times it by 9 to 27. And we're going to add those together. So we are going to get, keep the base the same, b to the 39 over 18 power. If that fraction can simplify, we want to simplify that right here. So I noticed that 3 can go into both of those actually. So 3 can go into 39 13 times, 3 can go into 18 6 times. So then I'm going, since that fraction is totally simplified, I'm going to now change it back to root form. That'll be the 6th root of b to the 13th. Well, b to the 13th is, let me write it really expanded here, is like 13 b's. 5, 6, 7, 8, 9, 10, 11, 12, 13. Here we go. And it's a 6th root, so in order to simplify this root, we can pull out identical factors as long as there's a group of 6 of them. So let me see how many groups of 6 b's there would be in 13 b's. 1, 2, 3, 4, 5, 6. Here's one group, here's another 1, 2, 3, 4, 5, 6. There's 2 groups of 6's, without going over, in 13. So each of those gets pulled out and it becomes 1b. So we're going to have 2 of those, so it's going to be b squared on the outside times the 6th root of b.